Great, let's continue from the previous session. This time, let's do the domain of radical functions. So we took time to understand what radical functions are, right? So take time to go through that. And then let's go back. Let's go straight into jumping into what we radical functions, how to find the domain of radical functions. Um, simple the radical functions are functions in which the input variable is found as a component of the radical. Like the when we have a radical function, that's they have square roots. So let's say f of x is equal to 3x minus 5, right? If you have this is just a linear function, or just let's say polynomial function. But then if you put a square root and over it, we are now having a radical function. Why? Because the input variable x, right, is found as a component of items that are found under the square root. So that's a radical function. So if I have something like this, f of x is equal to s root 5. This is not a radical function. Why? Because the function, the input variable that we are having is x, and it's not found under a denominator, but it is outside. In this case, it's just a simple polynomial function or a linear function. That's what we have here, right? A simple linear function. So that's a basic distinction that you can use to quickly glance through. When at a glance, you can see that okay, you need this. No, let me not delete this function, right? Let's use it to find the domain of the function of this function. So we have f of s is equal to square root of 3x minus 5. Uh, for radical function, you have to know something about square roots. Square roots generally what they do is that whatever, if you're talking about real numbers, right, in the domain of real numbers, for all real numbers, what happens is that we cannot have negative number under square root. If you have a negative number as a square root, it cannot be, it is not possible. I mean, when we are talking about real numbers, but then when you do that, when you have something like that, then it's a complex number. But we are not dealing with complex number. We are interested in real numbers, right? That's why in the domain we say x is such that x is a member of all real numbers, comma before the exception comes. So in this case, we're focusing on real numbers. And if you're talking about real numbers, the number that is under the square root here can never be what? Less than zero. It can never be less than zero. It can be zero, all right, but it can never be less than zero. It means that it can be zero or anything greater than zero. Do you follow that? It can be zero or anything greater than zero. That's what radical functions about, or basically square root. So I can have square root of 2 can be classified for belongs to like a real number. Okay. But then when you have square root of negative 2, it is not a real number because in this case, the number that we have under the square root is now negative. Okay. We can have square root of 0. This is valid. But now you cannot have square root of negative 1. And in this case, all these negative under the square root, um, they are all complex numbers, not real numbers. So yes, so that's why we don't even allow that when it comes to functions or numbers that's under square root. So we have to know that, let's say if you have a function like this, let me just use an example. Square root of it, and there is a number, or let's say expression e. The name of the expression is e. You have to know that the expression it can be 0 or it can be greater than 0, meaning that anything greater than 0, it can be 0 or greater than 0. If you combine these two together, if you combine these two symbols together, you are going to have a is greater than or equal to 0. E should be greater than or equal to 0. This is what we are going to use mostly for this particular thing. So I took you through how to understand why we are using that symbol, right? Yes, because we are focusing on real numbers, and real numbers need numbers that's greater than 0. So we are going to apply that on this first example. This first example, we have this particular expression 3x minus 5 and the square root, and then for it this one to be valid, right, for this one to be belong to a real number, you need to know that whatever is under the square root, that particular thing should be greater than 0. So 3x minus 5, it should be greater than or equal to 0. It can be 0 or it can be anything greater than 0, but it can never be less than that. So with this, you can solve for x. You have 3x, you send the 5 to the other side, become positive 5, then you divide through by 3, then you have 5 over 3. Then what do you think? The domain is the same thing, right? Like how we did this. This is the exception. So we say that x is such that x is a member of all real numbers, comma. Then you copy the entire result there. So you copy the entire result there. So I'm just going to comma x is greater than or equal to 5 over 3. This is the domain of this particular function. Let me look at an example. Let me take another example. Let's look at another example. G of x is equal to x squared minus root 5. So if you have this, what do you think will be the domain of this function? Our function is not, our input variable x is not under a square root, right? It's not under a square root. So this one is just straight. There's no exception. But then let me change it and actually give you as an example of a radical function so that we can continue. That's what we are focusing on. Square root of 3s minus 5. No, that's what I just copied. Wow, why is this thing coming to my head? Let me say 4x. Yeah, just 4x. Let's just have 4x, right? So what will I have? What's the domain of this one? Whatever is under the denominator, right? Or under the square root in this step. Sorry, square root, under the square root, right? Whatever is there should be greater than or equal to 0. So there, whatever 4x should be greater than or equal to 0. Then here you just divide through by 4 and you have x greater than 0 over 4. And so x is greater than or equal to 0. Therefore, our domain will just be x such that x is a member of all real numbers, comma, where x is greater than or equal to 0. Basically, this is what we have for these particular radical functions. Let's try another last example, then we can close docket on this. Let's say f of t is equal to 3t squared square root of 5x minus 2. So this is the first function that we have. In this function, what's the input variable? The input variable is t. And then if you look into the expression here, you see that the input variable is not is here, and then it is not under the square root. Since it's not under the square root, then what we have, we are not having any issue there. But then the input variable is here. So the domain is all real numbers. There's no exception. We've taken time to know about, find our way around these tricks, right? Look at the input variable and locate the input variable inside the expression. But then what if I change the input variable to x, then you see that the input variable is now x. So you have to know that our input variable is, in this case, is under the square root. So all the expression under the square root, will bring them out. We say that 5x minus 2 should be greater than or equal to 0. Then you just solve for x greater than or equal to 2. Then x should be greater than or equal to 2 over 5. Then the domain x is such that x is a member of all real numbers, where x is greater than or equal to 2 over 5. Yeah, this is the domain of our function. This is the domain of our function. Yeah, this is how to find the domain of radical functions. As simple as that. Let's remember, don't try to chew. Remember that any number that is under the square root, right? Yes, they have to be greater than or equal to 0. So next one, we are going to look at the examples where we are now seeing the input variable is under a denominator, right? It's under a denominator, and then in that denominator, it is still under a square root. We are going to see the combination of these both conditions in the next session. Stay with us, subscribe, and like. See you in the next video.